My name is Barabbas Lisi, and this is my Module 7 assignment. In this module, I will be running an Ancova test. Um, the null hypothesis is that there is no significant difference in the scores of students taught by Smith, Jones, and Brown. And the alternative hypothesis is there is a significant difference in the math scores of students taught by Smith, Jones, and Brown. And in this exercise, I'll be checking for homogeneity of regression slopes, of variance. I'll run the Ancova. I'll interpret the main effect and report the F, the degree of freedom, and the p-value and the partial n squared p. And I'll report the adjusted means and state conclusion. So the first thing that I'll do is go to Analyze. I'll go down to General Linear Module to Univariate. I'm going to move the test variable over to the dependent. I'm going to move the class to the fixed factors. And I'm going to put the periods missed over in the covariate box. I'm going to click on model. Okay, so after we've done that, we're going to start to move things over. So what the first thing I'll do is, just a second. So I've made sure that we've got full factorial clicked, and I'll hit continue. I'm going to click on the EM means, and I'm going to move class over to the display means for. I'm going to make sure we've got compare main effects checked. I'll use this drop down menu, and we're going to choose the Bonferroni. And we're going to make sure that we've got, again, we've already got compare main effects checked there. So we're going to go to continue, options, and I'm going to make sure I click on homogeneity tests, continue, and then I'll hit OK. Okay, so we can see here that there are 30 variables for each of these three teachers. We can see at our test between subjects effects and look at our rows here. And if we look at the class row there, we've got a degree of freedom of 2. Our F value is 4.116. The significant value is 0.020. And if we look down at our error row, we've also got a degree of freedom of 86. So based on the significance, we reject the null hypothesis that there is no significant difference in the math scores based on periods missed. We're going to go down and look at our estimates table and look at the means, and you can see the means 84.097, 79.931, and 80.472. So we do see that there is difference. We go down to our pairwise, and we're going to look at all of these to see if any of these is less than 0.05. And if there is one of these that's less than 0.05, that means that there is a significant difference in If we look at Smith versus Jones, we can see that we're at 0.029, which is less than point zero 0.05. So there is a significant difference between Smith and Jones math scores. Um, and those are the only two that we'll see that has served for. So there is a statistically significant difference between the three class math scores based on periods missed. Um, so based on that, the next thing we need to do is we need to look at the homogeneity of variance, and that should be under the Levine's test. And we can see the F value, degree of freedom, and the significance there. We also need to check for homogeneity of regression slopes. And the way that we're going to do that is we're going to do exactly what we did before. We'll go to Analyze, General Linear Module, Univariate. We're going to click on Model, Build Terms, and we've already got one selected here. What we'll do is move both of these over. And we're going to hit Continue. And OK. And the only thing that we're going to be looking for is the test between subject effects. And that's the class times the periods missed. And we can see that the degree of freedom is 3. The F score is 0.118, and the significance is 0.949. So that means that we did pass the test, and the Ancova was the correct test for us to use with this. So again, we did reject the null hypothesis, and this is a meaningful score, which shows that there was a difference in the mean scores of the tests, the math scores between these three teachers, uh, notwithstanding the periods missed.